Hello, this is the section 3.2 lesson. In this section we're going to talk about two very simple but very important properties of addition. The commutative and the associative properties of addition. And so we're going to start off by defining these properties or stating these properties, and we're going to talk about how they're used, and then we're going to finish this section talking about proper ways to write equations. So first of all, let's state the commutative property. The commutative property says that a number a plus b is the same as the number b plus a. And so what this property is saying is that order does not matter. We can switch the order a and b around and we're going to get the same thing. Another way of thinking about what this means is that adding in one direction is the same as adding in the other direction. And that's maybe one way to remember the name of this property, commutative property. Think about commuting to work or to school. The distance that you drive to school is the same as the distance that you drive back home from school. So this is like one direction, this is the other direction, and they're the same direction, or they're the same distance. The second property is the associative property. This one looks a little more complicated because it deals with expressions involving three terms. And this says that the quantity a plus b plus c is the same as the quantity a plus the quantities b plus c. So remember, when we have parentheses like this, that means that we do everything inside the parentheses first. So this side says we add the a and the b first. This side says we add the b and the c first, and then we add what's left. And either way, we're going to get the same thing. So this associative property says that we can group or associate these terms however we want. We don't have to add from left to right. We can add whatever terms we want, and we're going to get the same thing. So let's do a simple example that illustrates how we can use these properties to simplify some arithmetic. So here's an addition problem that we want to do, 367 plus 98 plus 2. Now, a real simple strategy is to just work from left to right. Add the 367 and then the 98 and then the 2, and that would be fine, but note that adding 98 and 2 is a lot simpler than adding 367 and 98. And so what we can do is rewrite this and say this is equal to 367 plus 98 plus 2, but now let's put the 98 plus 2 in parentheses. So when we put things in parentheses like this, we're using the associative property. The associative property says that we can group things however we want. Okay. Now, let's do this arithmetic. 98 plus 2 is just 100. And then 367 plus 100, well, that's easy to do. That's just 467. And so there's our answer. So the associative property allows us to group things however we want so that we can simplify our arithmetic. Let's do another example here where we're adding three terms, 153 plus 19 plus 7. Like before, we could work from left to right, but adding 153 and 19 is a little bit complicated. It'd be easier to add 153 and 7 first. So let's do this. Let's rearrange terms. Let's write this as 153 plus 7 plus 19. And so what we've really done there is switch the order of the 19 and the 7, which is completely justified by the commutative property. Okay. And now let's group things together. Let's do the 153 plus 7. Let's group those together, put them in parentheses, plus 19, and that's completely justified by the associative property. And now we can do this arithmetic. 153 plus 7 is 160. Plus 19, 160 plus 19 is 179. And so there's our final answer. So again, we see how we can rearrange terms and group them however we want to simplify our arithmetic, and that's all justified by the associative and commutative properties. Let's do another example this is adding just two numbers, but let's look at how we can rewrite things so that we can simplify our arithmetic a little bit. So 13 plus 17. Now this is fairly simple. We could do it in our head, but here's maybe one way that we could break this up. I think, well, 13 plus 7, 13 plus 7, well that's 20. That's pretty easy to add. So let's do this. Let's write this as 13 plus, and then the quantity 7 plus 10. So all we're really doing there is rewriting the 17 as 7 plus 10. And we know that's true just because 7 plus 10 is 17. Okay. Well, now let's regroup things. So 13 plus 7, let's put those in parentheses, plus 10. So we're regrouping things, and that's justified by the associative property. And then 13 plus 7 is 20. 20 plus 10, and then 20 plus 10 is equal to 30. And so there's our answer. So we see how we rewrote this 17, we broke it up like this, and then we regrouped using the associative property. We grouped because 13 plus 7 was very easy to add. It added up to 20, which is a multiple of 10, and multiples of 10 are easy to work with in our heads because our number system is a base 10 system. So when we break things up so that we get a sum that's a multiple of 10, we call this a make a 10 method. Make a 10 method. Okay. And so that's a common technique that students use and that we'll use in this class to simplify arithmetic. Make a 10 method. Okay. Now, as in all these examples, we've been writing a lot of equations. And so let's talk about what is an equation and some common mistakes that are made when writing equations and the proper way to write an equation. Okay, so here's a simple equation, 2 plus 3 plus 4, 2 plus 3 in parentheses equals 5 plus 4. Okay. Now, so you see what we did to go from one side of the equation to the other is that we added the 2 plus 3 to get 5. We didn't do anything with the 4. And so this is an example of an equation. Now, this left side is what we call an expression. I won't spell it all out, an expression. And then the right hand side is also called an expression. So an expression is like one side of an equation. Now when we set two equations equal to each other, this whole thing is what we call an equation. EQN. So in an equation we set two expressions equal to each other, or in an equation we are saying that two expressions are equal, and by equal we mean that those expressions represent the same thing. So let's state a couple of very, very important points to remember when writing equations. So number one, when writing equations, make sure that both sides really are equal. That's what we're in an equation, we're saying that two expressions are equal, and so when we say that we should make sure that they really are equal. And then number two, this is a point that I'm going to be making throughout the whole semester. Say exactly what you mean. If you say that two things are equal, then make sure they really are equal. And then vice versa, if you mean that two things are equal, then say that they're equal with an equation, with an equal sign. So let's look at a couple of common mistakes that people make when writing equations and some proper ways to write equations. So let's take this simple problem, 19 plus 11. And so we could do this in our head, but let's look at how we could write out our work and use the associative and commutative properties. Now let's say that a student wants to do a make a 10 method. And so they say, well, 11 plus 1, or 11 is 10 plus 1. And so what they might do is say, well, let's take 19 and then add 1. And so the 19 plus 1 is 20. So they made a 10. And then they say, well, I need to add 10 more because 11 is 10 plus 1. And so then they said, well, 20 plus 10 is equal to 30. And so there's their answer. Well, that's the correct answer, but they made a mistake there, two mistakes in their equations. Number one, 19 plus 11 is not equal to 19 plus 1. That's not at all true. These two expressions are not equal. So that's a mistake right there in saying that 19 plus 1 equals, or 19 plus 11 equals 19 plus 1. Okay? So another mistake is that they said 19 plus 1 equals 20 plus 10. Well, no, that's not correct either. This student maybe had the right idea, or this set of equations is kind of illustrating a correct idea or correct approach to adding these two numbers, but things are not said properly. Okay? So let's talk about a proper way to show our work here. Okay? So this whole method here was right idea, but wrong work. So let's show how we could do this properly. 19 plus 11 is, well, 19 plus maybe a 1 plus 10. Okay? So this expression here really is equal to this expression. We simply rewrote that 11 as 1 plus 10. Okay? And so now let's regroup things. So 19 plus 1 plus 10, and we can regroup things by the associative property. Okay? So this expression really is equal to that expression. Okay? And now we can do this, 20 plus 10, do that arithmetic, and then 20 plus 10 is 30. Okay? So there's the right answer. So we got the same answer as we did up here, but this work here is correct. This work up here was not correct. Again, when we write equations, we want to make sure that both sides really are equal. We said exactly what we meant, and we meant exactly what we said. Let's do another simple example here dealing with subtraction, showing how we can write proper equations. So 73 minus 18 is equal to what? And again, this is something we could probably do in our head, but let's look at how we can show equations to illustrate the steps that maybe we took in our head. So a student might say, well, subtracting 18 is almost the same as subtracting 20. So a student might say, well, this is equal to 73 minus 20. But then, so then they said 73 minus 20, that's 53. Okay, that's pretty easy to do in our head. But then they said, well, wait a minute, taking away 20 is a little too much. We didn't really want to take away 20, we only wanted to take away 18. So if I take away 20, well, then I need to add 2 more back to it, and so we get 55. So there's the correct answer. But again, we made a mistake here in showing our work. 73 minus 18 is not the same as 73 minus 20, and nor is 73 minus 20 equal to 53 plus 2. So that equation, those two expressions are not equal. We did get the right answer, but we didn't explain our work properly. So let's talk about how we could do this properly. 73 minus 18. And so let's say, well, 73, take away 18 is the same as taking away 20, but then adding 2 back to it. What we're really doing here is writing the negative 18 or minus 18 as minus 20 plus 2. And so this expression really is equal to this expression. Okay? And so now we can kind of group things together. Let's group it like this. 73 minus 20 is 53, and then plus 2, and then we do that arithmetic and we get 55. So there's the proper answer, and here's a proper sequence of equations that shows what we did. Up here we got the right answer, but our equations were not correct. So when we write equations, we need to make sure that both sides really are equal, and in those equations we should say exactly what we mean and mean exactly what we say. So that's it for this lesson. Your assignment before next class period is to read section 3.2 from the textbook, and then also read this handout titled section 3.2 Learning Paths. In this short handout, we're going to look at some different approaches that students take to doing mental addition and subtraction. Let's start with real simple approaches, a little more complex. And in one of those learning paths that we'll mention is the make a 10 method.